Hello, my name is Kurt Roloff. I am the CTO and co-founder of Duality Technologies.
Hi, I'm Dave Cousins, and I'm the director of Duality Labs, the contract R&D branch of Duality Technologies. We're the group that is developing the technology that will enable new Duality products in the years to come.
Hi, I'm Yuri Polakov. I'm the crypto lead in the Duality DPRIVE effort, and I'm the main expert in fully homomorphic encryption, math primitives, and advanced cryptographic procedures such as key switching and bootstrapping.
Our team at Duality has been involved with DARPA for many years, including many of the early hardware implementations of homomorphic encryption. In particular, we've been running a team funded by the DARPA DPRIVE effort called Trebuchet.
I'm the principal investigator for the Trebuchet project, which is the Duality-led team that is designing a custom application-specific integrated circuit, or ASIC, whose goal is to speed up the computation of FHE applications by several orders of magnitude to a point where they are only an order of magnitude slower than when run on a conventional single CPU in unencrypted form. My job on this program was to assemble the team, win the competitive contract, and keep the team on the path to success.
So a lot of effort has been put in designing this hardware abstraction layer, doing it in a way where other hardware acceleration backends such as GPU, FPGA, or AVX512 could still be added.
Recently, we completed phase 1 of the DARPA DPRIVE project and have been selected to continue on to phase 2 of the effort, indicating that we have shown high performance improvements of our designs worthy of moving forward into potential hardware implementations.
Duality lives and dies by its technological advantage. Having DARPA-funded research in hardware acceleration and the software required to utilize it gives us a major advantage over our competition in that it helps future-proof our software, positioning us to take advantage of new types of hardware as they become available. For the industry in general, we've seen over and over that hardware acceleration enables solutions that were initially dismissed as taking too long. We've seen it with GPUs for graphics, in cryptography with AES accelerators, and in tensor processing units for CNN training. These were things that took too long on a conventional CPU and are now commonly accelerated, often without us even thinking about it. Floating point computations used to require hardware acceleration. Now they're all built into most of our CPUs. So currently, we work extremely hard to reduce the time it takes for our secure collaboration products to generate real actionable results. Hardware acceleration will reduce this compute time even further, which means two things. We speed up what we can do now, accomplishing more in the same amount of time, or we can solve much harder problems in this same amount of time.
These applications could be used, for example, to support better public health decisions from sensitive data, building models of how, for example, epidemics propagate in societies. These capabilities could also be more broadly used to build better models of financial crime, thus allowing financial crime investigators to be more effective on identifying fraudsters who are attempting to exfiltrate money from unsuspecting innocent individuals.
We are in the second phase of the DPRIVE program, which ends in November 2024, where we will need to show that our design can meet performance goals of the 3 machine learning challenge applications that were spelled out in the program: logistic regression training, convolutional neural network inference, and convolutional neural network training. It will be very tough, but we have some of the world's leading experts on our team. At that point, DARPA will down select one performer and take their design to the foundry and fabricate the system for evaluation in the final phase of the program. Meanwhile, as part of the project, we have already developed hardware abstraction layers for the Open FHE library, which, by the way, is our core FHE software used in our products. This allows us to integrate with not only the DPRIVE accelerator ASIC, but also other hardware vendor solutions in a way that is supportable and extensible.
This hardware abstraction layer is a very general capability that allows easy integration of other hardware frameworks, such as GPUs, FPGAs, and more.
DARPA programs are by design high risk and high payoff. We embrace the build, test, build cycle, try different things, and all the time keep our designs fluid and adapt because FHE is a rapidly developing field where we need to constantly review our design decisions as we develop better understanding of our challenge problems.
Thank you. Please reach out if you have any questions at all, either through us at Duality or into the Open FHE community. Have a good day.